All right, today we're going to talk about angles of parallelograms, and so we'll get right into it. The opposite sides of a parallelogram are congruent, so that means that these sides here, so those two angles here, opposite, should be, that's not sides, it should be angles. Opposite angles of parallelogram, sorry. I mean, that's actually true also, but not what we're talking about, sides. All right, we're talking about angles. So if we know the upper left-hand one, then we know the bottom right-hand one. So we'll use that here later. All right, consecutive or adjacent angles of a parallelogram are supplementary. So that means that if this one is 115 degrees, that this one has to be 65 degrees because these are consecutive or adjacent. They're right next to each other. And so that would be because of 115 and 65, that's 0, that's 2, 8, and 1 is 180 degrees, which is supplementary, 180 degrees, in case you've forgotten that. Similarly, if you have a 60-degree angle here, this is a 120-degree angle there. So we can know what is happening really quickly. And in a rectangle or a square, you can know that since they're all 90 degrees, any two of them next to each other is 180 degrees. All right, so diagonals of a parallelogram separated into equal triangles. This is kind of cool. All right, so if we take a diagonal here, now we can see here that this triangle here is the same as this triangle here. They're same triangles. All right, so meanwhile, if you look at this one here, we cut those right across there like so, then we can see that this one and this one are the same, and then this one here and this one here are the same. So then, on a rectangle, which is the same basic idea here, so we can see here that these are here, and then we have those there, and those are the same. So that'll come in handy. Now, if you note here that diagonals of a rhombus are perpendicular bisectors. So if this is a rhombus, so all of these are the same sides, then these are all 90-degree angles. And that appears to be the case. Even if this isn't quite perfect, it appears close. And so that is correct. Then specifically here, we can talk about vertical angles. So if we separate these with a line here, then we have this angle here is congruent to that angle, and then you have that angle up there and this angle on the bottom. Those are congruent. Those are vertical angles. So they're the angles on the kind of opposite side of the transversal, if you will. And then the last piece here is that when you look at a rectangle, and we talk about this one and this one, guess what those are? These are isosceles triangles, right? Because the base is different. So this base is the same as that base, I guess. But so, but then the legs of the triangle are the same. I mean, so it makes isosceles triangles, and guess what? That applies the same for this triangle too. So if I change colors here, the green triangle is also an isosceles triangle, and they're the same congruent triangles. So pretty cool. All right, so let's see this at work. Let's do some practice problems here. So in rhombus LMNO, find angle M and the measure of angle M and the measure of angle N. So this little M here stands for measure, right there, right there. All right, so angle M, let's talk about it first. All right, so angle M, well, let's see here. This one plus angle M has to be 180 degrees. So if we solve that out, 110 plus M is equal to 180 degrees. I isolate the variable, I get M by itself. I subtract 110 from both sides. That leaves me with just M on one side and then 70 degrees on the other side. So the measure of angle M is 70 degrees. The measure of angle N, then, well, we can just do this one. We could actually do what we just did, but we could say the opposite angles, so back from the very beginning of here, are the same inside of a parallelogram, so, or a rhombus, either one. So 110 degrees. Okay? All right, so let's look at parallelogram ABCD, and we need to find the measure of angles A and B. So measure of angle A and the measure of angle B. Well, we get D, so I can quickly say B is going to be the same. All right, and then measure of angle A, since these are consecutive or adjacent angles, we can say that those 78 plus A is going to make 180 degrees. So I'm going to subtract 78, get A on one side, and I'm left with 102 on the other side. So A's measure is 102 degrees. All right, so let's make it tricky. All right, so in rectangle XYZ, find measure of angle QRX, RXQ, and then XYR. So measure of angle QRX, the measure of angle RXQ, and the measure of angle XYR. All right, so let's do this one at a time. So QRX is going to be QRX. Okay, so that's the angle we're looking at. That's really weirdly written. Showed up. All right, anyway, that one there. So check this out. We've got a vertical angle here that we can use. So these two are vertical angles. So that's going to be 125 degrees. All right, I'm going to switch colors. So I can do RXQ. So RXQ goes RXQ. So it's this angle. Well, this is a rectangle. So I know that this is a 90-degree angle, but it has 72 degrees of it already used. So if I take 90 degrees minus 72 degrees, then I will find that it is 18 degrees left. 18 degrees. All right, so now switch colors one more time. Let's go hot pink. All right, so XYR, so X, Y, and then R. So we're looking for this angle here. All right, so let's figure this out. We know this angle, 72 degrees, and we know that this is, so if I go, let's go yellow here. This is an isosceles triangle. Well, what do we know about isosceles triangles? Well, we know that this angle and this angle are the same. They're congruent. So I can say that XYR is 72 degrees. All right, so let me draw this other one. I didn't draw our rhombus here. Oops. Let me try that one more time. There we go. All right, and I can even make it like a little prettier. All right, so this is a rhombus, and it is GHKJ. Didn't go down here, did it? Okay. G, H, J, and K. And it's got some diagonals in it. So let's draw those. And we know that this angle up here is 33 degrees, and we're going to be told that this one is 47 degrees, and this one is 63 degrees. All right, so we need to find these three. So I'm going to write these in different colors. So angle, the measure of angle GSH H. And then we're going to do the measure of angle GKJ. And lastly, the measure of angle HJS. All right, so let's start with the first one, GSH. So, S is the middle. By the way, I didn't write that in there. Sorry. S is this point in the middle. That's important. So GSH goes GSH. So this is a rhombus. So this one's really simple. It's 90 degrees because they're all angle bisectors. So all of these are 90 degrees in here. That one's an easy one. No real math involved. All right, so GKJ. G to K to J. So this is the angle we want right here. Well, we know opposite angles are the same. So the opposite of this one is over here, but it's not just 63. It's actually both of these sides together right here, all of H. So that is a 47 degrees and a 63 degrees added together. So when I add those together, see that is 10 and that is 11, so it's 110 degrees. All right, now lastly, we need HJS, so that is this one to this one to this one here. All right, so what do we know? Well, we can do a couple of things. For example, these are going to be, so this one is going to be the same, this one here as this one here. All right, so how do we get that one? Well, if we look at this big angle here and this big angle here, these two should be, so G and H should equal 180 degrees. Except because they're consecutive or adjacent angles. But we don't have quite all of those. So for G, we have x plus 33. And then for H, we have both 47 and 63. Or we could just go ahead and add those together and make them 110. But I'll write them out this way. And that should equal 180 degrees. So this is 110 plus 33 plus x equals 180. Put those together, it's 143. And then I'm going to subtract 143 from both sides. And I'm left with x equals 33, 47, 63. Oh yeah, that's right, sorry. It should be 7, kind of borrowed that, so 37 degrees. All right. So that is that is this angle here, 37 degrees, and so that should be the same as this angle here. So that should be 37 degrees. All right, that was a tough one, but I think that's all the ways you're going to be asked to do it. So best of luck to you.